Okay, Team Impact. Today we're going to talk about the mean absolute deviation. I skipped stem and leaf plots because that's not one of our anchors. So to save a little bit of time and make up, we're going to go ahead and jump into the MAD, what we call the MAD. Okay, so the MAD, or the mean absolute deviation, is a measure that gives the average distance each data value to the mean. What I always call this, it's the mean of the mean. All right, first thing we're going to do is find the mean of the data set. So I'm going to switch to a red pen so you can see a little bit better. Okay, maybe blue. I'll use this one. All right, so I'm going to find the mean of this data set. So I'm going to add them up. 2 plus 4 plus 6 plus 7 plus 8 plus 15. Okay, so when I add all of those up, I get a value of 42. I'm going to divide that by 6, and 7 is the mean, right? 7 is the mean. Now, what we're going to do now is find the distance each one of these numbers are from the mean. So I'm going to rewrite these like this. All right, this is the easiest way that I have found to do this, right? And I'm going to do this, right? So whether it's positive or negative, I'm just going to write the number. I'm going to write the absolute value down. So 7 minus 2 is 5. 7 minus 4 is 3. 1 is 0. 7 minus 8 is negative 1, but I'm just going to put a 1 there. And 7 minus 8 is 15. So how did I get these numbers? I took 7, which was the mean, and I subtracted all of those numbers from it. Now, I'm going to find the mean of the mean. I'm going to find the mean of these numbers now. So now I'm going to add these up. Plus 1 plus 8. And when I add those up, I get 18. And there's still 6 numbers. 18 divided by 6 is 3. 3. So what did that tell me? That told me that the average distance these numbers are from the mean is 3. Right? It's the mean of the mean. It's called the mean absolute deviation, right? That's what it stands for. Let's roll on and let's go again. Okay? So what I would tell you is to go ahead and set it up like this. Let's set this up correctly. And do that. First thing I'm going to do is find the mean of that data set. When I add all of these numbers up, okay, I get 45. And I'm going to divide that by 1, 2, 3, 4, 5. 40 is 9. So now I'm going to take 9 and subtract all of those numbers from it, and I'm going to write the difference underneath. So 9 minus 2 is 7. 9 minus 4 is 5. 9 minus 6 is 3. 9 minus is 6. 9 minus that is 9. Now I'm going to add all of these numbers up and divide it by 6 again. So when I add those numbers up, I get 30. Divided by 6 is 5. The MAD is 5, right? Oh, there's only 5 numbers in the set. I apologize. So we're going to divide that by 5, and we're going to get 6. Excuse me. Glad I caught that. So the mean absolute deviation is 6. The average distance, our original set of numbers, is from the mean of 9 is 6 places. Okay? So I guess we could write it like this and put that there, right? Oops, didn't know you couldn't see. Take a peek at that now. So let's go to our next set, all right? And I'm going to skip set B, but I am going to go to set C, all right? So this is interesting, isn't it? 9, 9, 9, 9, and 9, right? I'm going to add all of those up and divide by 5. So this is going to equal 45. Divided by 5 is 9. So the mean is 9. right? This is an interesting one, right? So if I subtract all those from 9, I'm going to get 0, right? If I add all of those up, I get 0 divided by 5 is 0. So the MAD is 0 on that one because they're all the same number. There is no average distance from the mean. The average distance is 0, right? Is 0. All right? Now, interpreting the MAD, right? The closer the MAD is to 0, the less variation in the data. So the closer the MAD is to 0, the less variation. Less variation, that means less spread. All right, less spread. The numbers are closer together. How does an outlier affect it? The mean absolute deviation, it will raise it, raise or lower it, depending on if it's an outlier that's way higher or an outlier that is way lower. Okay, let's flip the page. Okay, we're not going to do all of these. I do want these guys to get done in class because it's a long weekend. Okay, so let's do 2 more of these, and let's just start with number 2. First thing I'm going to do is write my numbers down like this. I'm going to get organized like that. All right, I'm going to add all of these up, okay, on number 2. So when I add all of these numbers up, I get 72. Now I'm going to divide it by 6 because there are 6 numbers in the set. 72 divided by 6 is 12. 12 is the mean. Now I'm going to take 12 and subtract it from each of these numbers. So that's 11. That's 7. 12 minus 9 is 3. 12 minus 12 is 0. 12 minus 16 is 4. And 29 minus 12 is 17. Now I'm going to find the mean of these numbers right here, of these differences. I'm going to add those up. And when I add those numbers up, I get 42. 42 divided by, again, 1, 2 is 6, is 7, and 7 is the MAD. You can see that right there. So that's the best way to set it up when we look at this, okay? We didn't do 1. Let's try and do 1 more so I can get you guys rolling on the homework in here. All right, number 4. Let's find the MAD of the data set. Let's go. 8, 10, 9, 14, 4, 12. Find the mean. So when I add all of those numbers up, I get 57, and I'm going to divide that by 6, and I'm going to end up with 9 5/10. Right? Now, when we have a decimal, it's a little bit of a pain. Some might need to use a calculator. That's fine as well, right? 9.5 minus 8 is 1.5. This is 0.5, right? This is 0.5. This is 4.5. This minus 4 is 5.5. 12 minus 9.5 is 2.5. Okay? Add these up with your calculator, saving you a little bit of time by doing it for you. They add up to 15. 15 divided by 6 is 2.5, and the MAD of that data set is 2 5/10. So it is, right? So the average distance, these numbers are from 9.5 is 2.5. And that is what it's telling us, right? I'm short on time. So if you're at home doing this, I want you to do numbers 1 to 8 for homework. on homework number 4. Have a good day.